Hello everyone, my name is Oleksij Rempel and I am talking today about updating old drivers for even older hardware, how to do new and tricky things with the latest kernel. This talk is mostly a motivation talk for new kernel developers, so if an old proven kernel developer, then you probably want to leave this room right now. You can see in this talk what kind of pains you can experience by touching old code and probably see what kind of positive things you can take out of this. It will probably not hurt you much. Every old driver is a historically grown thing, so it is like a sensible old ecosystem, like this old wall behind of me, which is like 100 years old. Why does anyone actually need to change or update or repair something? Well, if you want to provide some kind of new functionality. Why do we have actually drivers which don't work or don't do things which we expect to do it now? Developing software takes time. It is kind of evolution which stops at some point, and we have no new updates or no new interfaces just because it is working good enough. The software is almost never completed. We can work and update it almost forever. Well, it is completed only if we stop and working on this. Usually, if we provide some kind of functionality or start creating some driver, for example, in the network driver case, it will be basic functionality like transmitting or receiving packets. Something more advanced like Diagnostic is not often implemented, or if it's implemented, it is not using new good unified interfaces. So if I want to have something like new kind of good unified diagnostic interfaces which are reusable for almost every system administrator, then I would need to port part of my code to use good proven file lib, create own driver for each file. So we can provide, for example, something like cable testing or provide MDI-X configuration capabilities, and etc. etc. In case of better Mac support, we can extend all drivers to use unified hardware counters, packet counters, and provide hardware or software timestamping. Starting from last year or something like this, we can use self-test, generic self-test support almost on every Mac, which currently not supporting this. Probably existing self-tests will be a bit harder to port, but it needs some more work and more time. So why FIRES? Why do I care about FIRES and what is actually is? From first look, it is kind of black box between cable and the Mac. Do it actually has a driver? Yes, it is. It is has a driver which usually integrated into file lib framework. Sometimes, or in older drivers, we usually didn't had own driver for the Phi. We just implemented this into the Mac driver. So here's one example, the ASIX, ASIX-based driver example. Yeah. At the beginning, as I took this task, it was almost perfectly working driver for ages. If I remember it correctly, it was integrated upstream for 15 years or something like this. And the Phi support is a tiny part of this Mac driver, which is enough to detect link status of the Phi embedded into this Phi, into this Mac. In some cases, there are devices with external Phis, and most of them are actually an not mainlined driver. It is provided by the downstream vendor driver. So we want to try to do something similar. We want to create own hardware based on ASIX X88772 with our own external Phi to do new interesting things. You can see this new fancy hardware on this picture. So let's attach different Phi and make new cool device. With the external ASIX, with the external Phi and the ASIX driver, we have different options. For example, we can do the same like it was done before and integrate some code into the Mac driver to handle Phi specific things inside of this. Or we can port ASIX driver to Philib and use Philib framework. So potentially we'll be able to reuse every driver, every Phi driver provided by Philib with ASIX driver. So let's do things properly and port ASIX driver to the Philib. What could possibly go wrong? Before my work was done, before my changes, ASIX was monitoring the link status by itself, and if some kind of changes was detected, the ASIX driver called MII eth_tool gset callback and tried to get all the generic Phi configuration and state registers. So as long as the Phi is implemented according to the latest standards, it would work. After the change, the driver is registering MII bus and connecting the Phi. MII bus was registered with MDO bus register function, and the Phi was connected with the Phi connect function by linking ASIX adjust link callback. The link change is now tracked by the Phi framework. It is the main difference to previous code, and the link reset function, which was used before, was replaced with the ASIX adjust link function, which is now called by the Phi framework instead of the driver itself. So after all of these changes, I triggered at least 6 regressions, which are fixed by now. And the question is, was it worth to do this change? I mean, do the pain I caused to other people by adding these regressions did some payback? And I will say yes, it is worth, because now we are able to support like every possible PHY with PHY framework, and we able to use cable testing or to do cable testing if the PHY is capable of doing this. And now the driver is using self-test, generic self-test support, so we can even run some self-tests and to see if our hardware is actually working. One other example is the switch. Why switch? Well, it is complicated enough, and it is kind of black box with even more ports, and it is part of it can be used as part of diagnostic for complicated network problems, or it is part of the problem itself. As my point of interest, I took one of old chips from Atheros R9331, which has like many integrated parts, MIPS CPU with 200 MHz or something like this. It has integrated switch for 5 ports, and it has even integrated Wi-Fi, but it is currently not interesting for me. So how much of this 11 years old chip can provide of how much functionality can this chip provide for us by using latest and greatest kernel? So I started this as a non-commercial project. This means I have kind of limitless time, and I can do this in between of work and my life. It is a hobby job. My point of interest of this chip is a switch, but to make switch work, I actually need to mainline Ethernet MAC driver as well. So instead of teaching one driver new things, I needed to teach 2 drivers. This is MAC driver AG71XX and the switch driver. If it is interesting for you, you can find not mainline PHY-based driver inside of OpenVRT repository. It is you can see this on the screen, and the new mainline driver after end of this work is inside of mainline kernel as part of the DSA framework. After starting this job some years later, the MAC driver AG71XX is mainline. It was based on the OpenVRT version, which was not mainline before, and I removed PHY and switch specific functionality from downstream driver, and reused the PHY-lib and DSR frameworks where it was appropriate. And I removed ETH tools and backface interfaces to make, first of all, mainlining easier, and to review and properly integrate this functionality into related frameworks, and if needed, to create needed interfaces. The switch driver was written from scratch because I was not able to reuse code of the PHY-based driver, and at the end this new driver has a bit more functionality as the downstream driver. The new driver is using some standard tools like IPRoot2 and ETH tool. So based on this experience, which was made with these 3 drivers, I would say that many of currently mainline Ethernet drivers, old Ethernet drivers, can be updated by using filelib framework, and it is possible to migrate at least part of them to use unified stats64 interface to provide reusable counters for every driver, every interface. Yeah, so you can just use IP tools and see this counters working. Don't forget about flow control. It looks like it is not really properly implemented by many drivers, probably because it is not so trivial to test it, and it needs some experience and attention to make it properly. And from now it is possible to port almost every driver to use generic self-test code, which has at least some basic functionality like sending IP, TCP, UDP packets over loopback provided by the PHY. Potentially we can use even other kind of loopbacks, for example, provided by Mac or other levels of PHY, but this need more discussion and needs better integration, so which is not currently implemented now. What kind of lessons did I learn from all of these projects? First of all, it takes time. It takes time and money sometimes. It depends if your company can give you some time to do this work, so it will cost your company this money. You will probably make some people unhappy because old interfaces was used, and the new interfaces should be learned. So old scripts may break also. In case of mainline drivers, this will probably trigger other kind of discussion if you allowed to break these interfaces. But if this driver was never mainlined, then you should break these interfaces to be able to mainline this driver, and you should use actually new and latest frameworks. At the end, there's not only negative parts. You will have a lot of pleasure using this hardware with latest and greatest tools and running the latest bleeding edge kernel on your Stone Age hardware. My motivation to do this kind of work, even by spending my personal time, is imagination that I sitting in some airplane or train which is crashing, and the reason why it's crashing is my failing driver, and I blaming myself not doing this, not implementing this properly. If you want to see what kind of work was done for these three drivers, for ASIX, AG71XX, and DSA RF9331 switch, you can see all of these links on this page, or you can use this git log snippet to read of changes, commit changes for ASIX driver. Or if you download this presentation as PDF file, you'll be able to click on these links. And as usually, don't forget to subscribe and press on this link to subscribe yourself to the NetDev mailing list to see all of the cool work which is done by all of these developers who are working on network stack. Thank you, and do you have any questions?